The collecting of minerals is for many people a fascinating and rewarding hobby. Here in Greensboro, North Carolina, Jim Irvine, a chemist by profession, has collected literally thousands of mineral samples from all over the world. We asked him to tell us a little about his hobby.
Well, we actually got started in collecting rocks because we had a 9-year-old Cub Scout. This is when we lived in Pennsylvania, and our 9-year-old had to complete a project for making a collection of 25 of something. And he chose to collect rocks. And so he went out to the driveway and he brought in 25 driveway rocks, which we immediately rejected because we explained to him that a collection meant that you had different items and you were able to identify them. And then we also said the thing that gets parents into things pretty deeply. We said, we'll help you. We scoured the countryside. We pulled poison ivy vines off of old dumps. We did about everything that might be imagined in collecting. It became a family hobby. The mineral collection grew and grew. When my company allowed me to transfer from research to sales, they were kind enough to move 3 tons of rock from Pennsylvania to Wisconsin. And when they moved me from Wisconsin to North Carolina, they moved 4 tons of rock. Now I would estimate that we probably have 6 tons or more of specimen material in our basement.
Once you've collected the material, what do you do then?
Well, if you go on a field trip and collect a number of specimens, the first thing you're going to do is clean them up with ordinary light delicate detergent and water. You can use a wire brush on them or a scrub brush on them and clean the mud out of the crevices. But if they're iron stained, for instance, there are ways to clean the iron stains off. You'd use a little bit of oxalic acid and that'll change the iron salt from a yellow stain to a colorless material.
Well, suppose you don't know what the specimen is. How do you go about identifying an unknown?
If I had found the mineral in the field and I needed to identify it, I would first of all examine the mineral to determine what physical properties it has, look at it from the point of view of its luster, metallic or non-metallic, its hardness, its specific gravity, cleavage if any, crystal structure. These are all clues as to what the mineral may be. And of course, when you refer to the literature, such as the real Bible on the subject, Dana's textbook of mineralogy, it contains tables, and by the process of elimination in going through these tables, you can arrive at 1 or 2 possible candidates for your mineral specimen, and then if you really still are in doubt, you can apply a simple chemical test. For example, here are 3 rocks that were brought to me by a Boy Scout. He asked for some help in identifying these materials. 2 of them appear to be black, and 1 of them appears to be a dirty white. Just in picking up these specimens, this one in the center appears to be considerably heavier than the other 2. It also has a submetallic luster. Let's see how easy it is to scratch this material. It seems to be about the same hardness as my pocket knife and harder than a penny. The textbook indicates that in the tables that a material with a specific gravity of 4 or 5, that is heavier than normal rocks, black with a submetallic luster, might be magnetite. It also indicates that magnetite gives a black streak, which is the true color of a mineral. So we'll take this unglazed porcelain and scratch it with this thing to see if it gives a black streak, and sure enough it does. If this is magnetite, it would be attracted by a magnet, so let's check that. Obviously, this magnet does attract it rather strongly, so let's tentatively assume that this is a piece of massive magnetite. Now let's look at these other two materials. They're about the same weight. This one appears to be broken in somewhat curved planes and has a glassy texture here in certain areas, which would indicate that it might be obsidian. Let's check the fracture. Obsidian is well known to have a conchoidal fracture. And we do get an example of conchoidal fracture right here, showing exactly. It has some transparency. You can see light through the edges of this material, so we'll assume that this is obsidian. Now the third material shows some evidences of cleavage planes. Cleavage planes are caused by the fact that a specimen has weak atomic bonding along certain planes, and there are millions of these planes parallel to each other wherever a distinct cleavage plane occurs. Let's wrap this thing and see if it'll break off in cleavage planes. There's a continued cleavage just exactly as it appears to occur. Let's check it in another direction. Well, we broke the whole thing. There, it cleaves in another direction. Here are three distinct cleavage planes, not perpendicular to each other, rhombohedral cleavage. I would assume that this is calcite. Let's confirm it with a hardness test. Pocket knife, approximately 5.5, scratches it very easily. A penny, 3.5, scratches it but not quite so easily. Takes more. My fingernail, 2.5 to 3, does not scratch it. It has about the hardness of calcite, the cleavage characteristics of calcite. I'd assume that this is calcite.
Jim has collected mineral specimens from all over the world. His collection is too extensive to see all at once, but he agreed to show us some of the best ones.
Now these are some of our favorite, or you might say prime, or our best specimens that we have collected. This specimen of azurite from Superior, Arizona is one of our all-time favorites. This was collected by trading through the mail. Another specimen with which we're highly pleased is this specimen of pyrophyllite containing pyrite crystals. We collected this in Glendon, North Carolina in 1971 when the Piedmont Mineral Club conducted a trip. In general, we have specimens from other parts of the world too, most of which we've acquired by trading. Here's a specimen from England. Here is a specimen from Tasmania. Both of those were acquired by trading. Some legrandite crystals from Mexico, which we acquired through taking a trip.
Not all collecting is done for purposes of putting specimens on the shelf. Some minerals are cut, polished, and made into jewelry. That phase of the hobby is called lapidary work, and Jim Irvine has become quite an expert at it.
My procedure consists of 5 or 6 simple steps. The first is to select the rough material that I intend to make into some jewelry. I orient that properly and put it in my saw. I use 3 diamond saws, and I cut the stone into various shapes. It's a 3-step cutting process. I cut a single plane first, and then I cut bars, and then I cut across those to cut into squares, rhombs, rectangles, hexagons, triangles, whatever I may be making.
After sawing the rough shapes, a large number of these stones are put into a tumbler filled with water and some grit, and left to tumble over and over for several weeks. The solution is changed 2 or 3 times using finer and finer grit until the stones are perfectly smooth.
Subsequent to that, I wash them up, clean them up, and place them on the table for my friends to use as a selection area out of which they can make jewelry when they come to visit. And then I have the findings and the stones, and we cement the stones together, or we cement them to the findings. We put bell caps on them and design jewelry. That is where the design department enters the picture. But actually, originally in my cutting, I'm thinking of what my stones are eventually going to be like when I go back to that first step and put the rock on my saw.
You've been collecting and cutting rocks and minerals for a number of years. What keeps you interested in rock hounding?
I think the thing that makes rock hounding interesting is the fact that it's a hobby with absolutely unlimited horizons. There's always something new to be learned in it. Right now, I'm experimenting with developing color in the lapidary end of the rock by taking agates and seeing what I can do to develop permanent colors in them. There's just no limit to how much can be learned. One could study crystallography, one could specialize in the chemistry involved in one type of mineral. It's just, I think the thing that makes it interesting to everyone is its wide vista.